Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom object detection model for YOLOv8. But before we move to our practical friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So as I mentioned friends, we are going to create our own custom object detection model for YOLOv8. For that, first you need to install latest opencv and YOLOv8 on Windows machine. This is what Windows 11. Of course you can go with Windows 10 machine also. So I have already created a video how to install opencv and YOLOv8 on Windows machine. I will mention video link, watch video and install opencv and YOLOv8 on Windows 10 or Windows 11. Okay, so for today's session I have created here a repository, and the repository name is YOLOv8 custom obj count. Okay, so I will mention link. You need to simply copy and paste link inside the browser, then go to the code, then we are going to click on download zip and it will download our zip format folder. So just go here, show in folder, then right click and we are going to extract our folder. So just like extract and it will create our folder. So this is what our folder, YOLOv8 custom obj count main, same folder again, and inside that I have mentioned coco.txt file. Basically this is a blank file, there is nothing inside right now. We are going to mention our object name. Then this is what the img.py is, basically capture our object images using our USB web camera in real time. And then this is what the main Python script. Inside the script I have created the basic code for YOLOv8. As I mentioned, I have already created a video how to use YOLOv8 for object detection with pre-trained model. I will mention video link, watch video and then you will get the idea how we can use YOLOv8 pre-trained model with the help of opencv and Python. Then this is what our Google Colab file for training purpose. Okay, so first what we are going to do, we need our images for our model. So we are going to capture our images. So let's just open img.py with our Thony Python IDE. Okay, and what we are going to do, I have here Arduino IDE board, then ESP32 board, and I have here a DC motor. So this is the three objects which we are going to detect. So we need here these three objects images. So simple, this is the code. With the help of this code we are going to capture a live images. So max frames is equal to 30. It means it will capture each object 30 frames. If you want to go with more, then you can simply mention the number. So let's say if I mention here 130 130, then it will capture each object 130 images, means it will capture Arduino ID 130 images, ESP32 130 images, DC motor 130 images. So right now we are going to only mention here 30 images for each object, for Arduino, then ESP32 and then DC motor. Then cv2.imwrite, this is the command which basically save our images inside our folder. So we need to create here a new folder. So basically what we are going to do, we are going to create our new folder inside our repository, the repository which we clone, or we can say which we download. So this is what our repository, YOLOv8 custom obj count main. Here we are going to create our new folder. So new and folder name, folder, let's say img. This is what our folder name. Okay, and then right click and copy as a path, because we need to mention here our path. So here this is basically our object name Arduino. So this is what our first object, and here this is the full path. Okay, so we are going to remove this old path. Okay, and we are going to mention our new folder path. So just remove it. Okay, and just paste, means I am going to press here Ctrl+V from keyboard. That's it. And then remove, just double quote over here, and that's it. Okay, and this one also. So now this is what our folder path. Okay, in C we have users feed folder, then downloads folder, YOLOv8 custom obj count main. This is what our repository. Inside that we have again same folder name, then we have img folder, and inside that we are going to first create our Arduino board 30 images. So for that we need to mention here our object name Arduino. So if I want to capture ESP32, so I am going to simply remove Arduino and I am going to mention here ESP32. Then it will capture ESP32 all 30 images. So simply we are going to first start with our Arduino. So let's say Arduino. Okay. Now what we are going to do, I have connect my USB camera with Windows machine. So when we run our code, when we run our script, our USB web camera will start, it will capture the live frame. So what we want to do, we want to simply move our Arduino IDE board in front of the USB camera in different angle slowly. Then it will capture a different angle Arduino IDE images. So now I will start a code. So friends, as you can see, I have captured Arduino IDE board 30 images. Okay, so if I open our folder, so just open file manager, inside downloads we have our YOLOv8 custom obj count main. This is what our img folder, and as you can see we have captured here Arduino IDE all 29 images. Okay, now simply what we are going to do, we are going to change our name, object name. So here I am going to mention ESP32. So now we are going to capture ESP32 30 images. Okay, so let's just start our code. So friends, we have done with ESP32. Again, if I open file manager, downloads, then our folder, same folder and img folder, and now here it is. As you can see, we have ESP32 29 images. Also we have our Arduino IDE images. So now what we are going to do, we are going to capture our DC motor 30 images. So let's just change ESP32 with DC motor. Okay, so if I save the code and if I run the code, so friends, we have done, we have captured our DC motor images also. So again, in file manager, downloads, same folder, img, and here it is. As you can see, this is what our last object image, 29 images with DC motor. So we have done with data. Now what we are going to do, we are going to use here a roboflow for training purpose. Okay, so now we are going to simply open our roboflow. So friends, as you can see, I have opened here a roboflow website, roboflow.com. Then just click on sign in, and you need to sign in with your Gmail ID. Okay, so here I have already signed in with my Gmail ID. So here we are going to create a new project. Then we need to select object detection bounding box, because we are going to use here YOLOv8 with bounding box. And then what we are going to detect here, so let's just say electronics. Then project name, so let's just mention project name YOLOv8 custom obj-detect yt. This is what our project name. You can mention any name, simple. So create a private project. Then here we need to now upload our folder, the folder where we have our all images. Okay, so simply I am going to open downloads YOLOv8 custom obj count. Okay, So this is what our folder img. Simply we are going to drag and drop. So just drag and drop. That's it. As you can see, it's now processing. So this is what our all images. Simply click on save and continue. So friends, done. So now here what we are going to do, we need to assign our images. So let's just click on assign images. Here you need to mention your name, or you can mention any name, and then you need to mention the Gmail ID, your Gmail ID. As you can see, I have mentioned Freedom Tech, and this is what Gmail ID. Simple. So just click on assign images. Now it will assign the images. That's it. We have successfully assigned our images. Now we are going to draw a rectangle on our images. Basically we are going to create here annotations. Okay, so as you can see right now, annotated 0 and unannotated all our images. So just click on first image, then it will open this kind of page. Here we are going to select the first bounding box method. So select it, and then we are going to simply draw a rectangle on our object, which is our Arduino. As you can see, I have drawn the rectangle, and here we need to mention our class name, means our object name. So our object name is basically Arduino. That's it. Click on save. Then next, same way, just draw a rectangle on the object, same name because this is the same class, Arduino. Save. Next, draw rectangle, save. Next image. Okay, so this is how I am going to draw a rectangle on our Arduino image. Then we are going to move on our ESP32. Then we have our DC motor. So let me first draw the rectangle on our Arduino board. So friends, we have done with our Arduino board. Now as you can see, we have here DC motor. So let's just draw a rectangle on our DC motor, and here we are going to again change the class name. So DC motor, simple. Save. Next, again draw a rectangle, save. Next, draw a rectangle on our DC motor, save. Next. So this is how I am going to draw a rectangle on our DC motor. So friends, as you can see, I have done with DC motor. Now this is what our ESP32. So let's just draw a rectangle on ESP32, and here we are going to mention our new class, which is ESP32. Then just click on save. Go with next image. Same way, draw a rectangle, ESP32, same class. Next image, draw a rectangle, same class. Save. Next image. So this is how I am going to draw a rectangle on our ESP32 board. So friends, we are done with drawing rectangle. Okay, I have completed our last image. Now simply click here, and as you can see, we have completed our images. Now simply click on add 90 images to dataset. So just click on there, and then we are going to click on add images. Done. Now click on generate new version. Now here add processing step, click on continue. Augmentation, click on continue. There is no need to change anything over here. Click generate, click on generate. Now it's generating our data set. Done. Now we have done with our image processing. Now we are going to open our Google Colab. So friends, I have opened Google Colab. So click on upload, click on choose file, and select our file from our repository YOLOv8 custom. Okay, so just select, click on open. Done. We have opened our Google Colab file. Then go to the runtime, then click on change runtime type, select GPU over here, click on save, and then click on connect. So friends, as you can see, we have connected. So we are going to now run our cell one by one. So first cell, just click on here. Done. Now we are going to install our ultralytics package. So second cell, So friends, done. As you can see, we have successfully run our next cell. So now move to next one, just scroll down, and here from ultralytics import YOLO. Now we are going to import our module. So just click on here, done. Now we are going to run our next cell. So here, with the help of our by default pre-trained model, as you can see, YOLOv8 and PT, we are going to test our YOLOv8. Simple. So for that, we are going to use a roboflow doc.jpeg image with the help of YOLOv8 and .pt, which is pre-trained model. So just select next cell, click on here. So friends, we have done. So if I scroll down, and this is what our image, and from image, as you can see, we have dog, and we have person. That's it. So now we are ready, and if I scroll down, so here we are going to now we need our data set. So for that, we are going to install roboflow, and we are going to use our roboflow code. So for that, again, we are going to move on our page, which is roboflow, and here export, as you can see, click on export, then select the format. So format is basically YOLOv8. That's it. And then select the show download code, and then click on continue. It will generate the code. That's it. As you can see, this is what our code. So from roboflow, import roboflow, just copy, okay, just copy it, copy like this way, open our Google Colab, and this one from roboflow we want to delete and just paste our own code, which we copy from this page. As you can see, your download code. So just copy and paste here. That's it. Now simply run the code. So friends, as you can see, we have done. So if I click here on the folder, as you can see, we have here dataset folder, because we create a dataset folder. So dataset, we have our folder YOLOv8 custom obj detect yt1, then we have test folder, then we have our images, and as you can see, we have Arduino, DC motor, and ESP32 board images. Simple. So we have done with our data. Now we are ready, and we are going to simply create our own custom model. So last cell, just run. Here we are going to create 100 epochs. So just run our last code, and it will create our own custom model. So it will take some time. It will basically create 100 epochs. So it will take some time. Meanwhile, I will pause video. So friends, as you can see, we have done, we have created our own custom model. So our model is basically saved inside runs, detect, and train folder. So just we are going to click here folder, and let's just make like this way. So runs, detect, and train. So as you can see, we have a runs folder, just click here, then we have detect folder, so just click, then we have train folder, select it, and then inside the train folder we have weights, and we have our model best.pt. Select here, click on download. Now it will download our custom model. So friends, as you can see, we have downloaded our model best.pt. So select show in folder, and we are going to simply move our model inside our repository. So just right click, click on cut, and this is what our repository YOLOv8 custom obj count main, open same folder, and just paste our custom object detection model best.pt. Now we are ready, and I am going to first minimize the browser and all other things, okay, and this is what our Tony Python ID, and we are going to open our now main script, which basically we are going to use for object detection purpose. So just go file, click on open, and then test. This is what our main Python script, okay. So now I am going to close the img.py, because we have done with img.py. So this is what our basic code. I am not going to explain all things, because I have already explained all these things in the video, okay, in previous video basically. So here it is, as you can see, I have mentioned YOLOv8.pt. this is our pre-trained custom model. So here we are going to mention our base.pt model, because we have now our own custom model base.pt, which we move inside our same repository. So base.pt, then we have here basically our rectangle. As you can see, we have our rectangle. Then we are going to use here our camera. So cap is equal to cv2.video capture. 0 is basically for one camera, because I have here only one camera, okay. So we mention our own custom model. So we are ready basically, and now we are going to run our code. So let's just save the code, and if I run the code, and friends, as you can see, it started our web camera, and here it is what our Arduino board, okay. So we have here error basically, and the error is why, because inside our coco.txt there is nothing, okay. So that's why it says index is out of range. So what we are going to do, because there is nothing inside right now in coco.txt file, it's completely blank. So we are going to comment our C, because our C is basically a class. It will read our class names from our text file, which is coco.txt, okay. So I have comment class list, and here what we are going to do, we are going to mention here D. D is basically our object ID, So we have object ID because we create our own custom model. So it will create by default with each object and their ID. So we have ID, so D is there. So I have mentioned here D. As you can see, I have removed this C, because right now we don't know the class, how we want to mention the class. 0 is for what, 1 is for what, and then second is for what. So we need the idea when we mention our class ID, okay. So I have comment the C, and then I have mentioned here in the put text method I have mentioned D. So D is basically our object ID, okay. So if I save the code, if I run the code, so friends, as you can see, it started our camera, and as you can see, we have here Arduino board, and on Arduino board we have ID. As you can see, there is a 0, okay. Top left corner we can see there is 0. So 0 is basically our Arduino ID, okay. So then we have here ESP32 is detected, ESP32, and as you can see, on top left of our rectangle corner we have 2. So 2 is basically the ID for ESP32. Then we have here our DC motor, as you can see, is detected the DC motor. So DC motor, on DC motor, as you can see, we have 1. So 0 is basically our Arduino IDE board, and 1 is basically our DC motor, and 2 is basically our ESP32. Now we can mention our class names inside our coco.txt file. So just open coco.txt, downloads, and same folder, and this is what our coco.txt. So 0 is basically our Arduino, okay. Then 1 is basically our DC motor, and the second is basically our ESP32. So ESP32, that's it. Now we have our class names inside our coco.txt. Now we can simply just click on save. Now we can simply mention over here our C. C is basically our class names. So we can uncomment our C. So if I save the code, if I run the code, and now as you can see, on the top left corner there is a class name which is Arduino, and as you can see, we have here ESP32 on left corner, top left ESP32. Then we have here a DC motor. On top left corner there is a DC motor. So this is how, friends, you can create your own custom model for your own custom object. Remember one thing, I have created here only 30 images. In real scenario, you need more images for better object detection purpose. Okay, I hope you learned something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.